Good day, ladies and gentlemen personalities. Today we are going to be dealing with how to find the equation of a tangent to the curve. All right. Now, what is a tangent? Let's start there. A tangent is any line that touches what? That touches the curve or that touches the graph where? At one point. Okay. You can see here, we've got an example of a tangent here. It touches what? The curve at this point. So we call it what? A tangent. Okay, it does not necessarily have to touch it here. It can touch it here, it can touch it here, it can touch it here. We don't care. As long as it touches it at one point, then we refer to it as what? As a tangent. All right. So how do we find the equation of a tangent? Now, let's use a question for that. So they are saying here we must find the equation of a tangent of f at x is equal to minus x squared plus 2x plus 3 at x is equal to 2. So we're giving a function and then we are giving an x point of that point where this tangent touches this graph. All right. So this graph is something that is more or less like this. Right. Okay. So we said earlier that a tangent is what? A tangent is a line. So by virtue of being a line, ladies and gentlemen personalities, that means that the equation that it will take is the equation that is y, which is equal to mx plus c. So if we do want to find the equation of this tangent, you will have to find the value of m and then the value of c of this line that we do not know at this point. Now the question is, how do we find the value of m? How do we find the value of m? All right. As we said earlier, this is a curve. So in general, how do you find the equations? How do you find a gradient in what? In curves. Okay, so let's say for argument's sake you've got a curve like this one. Okay, it doesn't matter what it is. Okay, but we're just gonna put it like this and then just like this. Oh, okay, and then put it like this, and then let's call it f at x. Okay, and then let's say that this is y, and then this is what? This is x, and then this is 0. Now, the only thing that we know about m is from traditional formulas, that when you have m, then you have a point. M, we said m is a gradient between 2 points. So you'll have point 1 that has an x value, so we've got x1 and then y1, right? And then you'll have point 2, which will have x2 and y2. And then using this point, then you will then go and find m, which is nothing other than y2 minus y1 over x2 minus x1. So if you've got 2 points, in that line, then you will definitely be able to find the gradient, no problem. But now, ladies and gentlemen, we have a curve. How do we then apply the same thing in the curve? It seems as if we're also going to do that. We're just going to try and find 2 points. Okay, let's try and find these 2 points. Okay, let's take this first point and call it A. Let's say the point is A. Let's put it here. The x value of this point is A. Okay, now if this is A, therefore the y value of it is what? Is f at A. Can you see that? All right. So we've got a first point, the point that we're going to use. Now, remember, we are looking for what? A gradient. So we need a second point. So here's the second point. Okay, so what we are simply going to do, on top of this a, we're just going to add h. H can be any number. So if we add a plus 2, if our h is 2, then it's going to be a plus 2, and so on and so on. If our h is 3, then it's going to be a plus 3, and so on and so on. But basically, you end up with a point which is a plus h. Why? Because you took a and then you just added a distance from a, which is what? Which is h, and it can be anything. Okay. Now, if you have this point a plus h, then the y value that corresponds to that point, so that you can find the gradient, is going to be what? It's going to be f at a plus h. Okay. So when you look at this formula to find a gradient, in this particular case, so our point there, you're gonna have you're gonna have point 1, but your point 1 now is what? This is your point 1. The x value there is what? Is a. Can you see that? And then what about the y value? The y value is f at a. Can you see? And then point 2 now is going to be what? It's going to be a plus h. Can you see that? And then what about the y of point 2? The y of point 2 is f at a plus h. Don't lose sight. What are we trying to do? We are trying to find m, the gradient, okay, of a curve, of this curve f at x. So since we already have the formula, so in this particular case, what will happen is that our y2 is going to be what? Our y2 is going to be f at x plus h. And then what about our y1? Our y1 is f at a, so minus f at a. Okay, and then all divided by, and then what about our, and then you've got x2. What is our x2 here? Our x2 is a plus h, so it's going to be a plus h minus the minus of this formula, and then x1. What is our x1? Our x1 here is a, so you've got a. And then what happens? So a minus a is what? Is 0. So you end up with something like this. You end up with f at, not f at a here, f at a, not x, f at a plus h minus f at a. But now because a minus a is 0, therefore you have what? You have h. So this is what? This is something that looks like a sort of a gradient. Okay. So you've got something, it's not necessarily a gradient at the moment, but it's something that relates to a gradient. Let me just put it here. This is what we have. Okay. It's not yet the gradient of this one, but if we just pick these 2 points and then put them here in a gradient formula, you will get something that is like this. Okay. Now, what is it that will happen from here? So, ladies and gentlemen, personalities, this is an approximate of a gradient of this one. It's not a gradient, it is an approximate of a gradient. Now, what can you do next? So what you can do next is you can then introduce another point, say maybe here. Okay? And then you can find the x and the y value of that point, and then you can find an approximate of a gradient. Now, what you will find out from there is just that we don't have time to do that. The approximate of this gradient here is going to be much better than this one. Okay, remember, when you've got an approximate, you've got it's like an estimation. You are estimating, so it's an estimation of a gradient. There is a true gradient at this point, right? But now, because you've picked 2 points, you will find an estimation, or an estimation of a gradient. So the estimation when the point is here, it's going to be much better than this estimation. And then when you can bring the point here, then you're going to get a much better approximation. When you bring it here, you get a much better approximation. But the fact of the matter is, if you make this distance, remember, between this and this, the distance is h. If you make this distance smaller and smaller and smaller, then you will get the true, the true gradient of this curve. Okay, now how do you then explain that mathematically? You will therefore say the true gradient of this thing, let's say this is m approx, because it's not m. All right, so now the true m, how do you then find it? You say you find it when you make the difference between these 2 points smaller and smaller and smaller. And how to explain that mathematically? You say m is what? Is a limit of what? Of this thing that we have already found, which is f at a plus h minus f at a all over h as h tends to 0. H tends to 0 means h is getting smaller and smaller and smaller. So the true gradient is therefore a limit of f at a plus h minus f at a all over h as h tends to 0. All right. Now, we then, when we actually take this and compare it to any other things, we find out that this is nothing other than f prime at what? At a. Okay, so the derivative of this function f at x at point what? At point a. Right? So now, in general, and going forward now, we therefore say, let me write with the red, then f prime at x, if we can take any value along the x-axis, is equal to what? So basically, the gradient at x is nothing other than f prime at what? At x, which is nothing other than the limit of what? As h tends to 0 of f at, now because there is x here, what do you put? You put x plus h minus f as x divided by h. Okay, and then do you remember this from somewhere? Yes, you do. Where do you remember it from? You remember it from first principle. Remember, in the first principle, we were finding what? A derivative of a function. Do you understand? So basically, from this thing, we find that a derivative is nothing but the gradient of that function at that value of x that is specified. Does that make sense? Let me repeat this one. A gradient a derivative is nothing more than what? Is more than like a gradient of a function at point x. Okay, so a derivative and a gradient is literally the same thing. It's just that the derivative is the gradient of a curve. Does that make sense? Okay, so now, which means that if I can get the derivative of a function, if I'm looking for a gradient of a tangent, now at this point of contact, the gradient of this line, so if I have a point of contact here, okay, let me use a different color. So if I have a gradient, right, and then I've got this function, then these two functions, the gradient of this function at this point is same as the gradient of what? Of this line at this same point. Okay, so if I find the gradient of this function, therefore I will find the gradient of this line. So because I don't have any information about this line, the only choice that I have is to find the gradient of this line, of which I will find it by what? By doing what? By finding a derivative at this particular point. Okay, now let us do that practically and see where we get to. Remember, we were supposed to do what? But before that, let me emphasize this theory. At a point of contact, this is very important rule. At a point of contact, f at x and the tangent shares. What do they share? Let me write with a different color. They share m, which is what? Which is the gradient. So they share the gradient, or they have the same gradient. Let me write that one as well. Or they have the same gradient. Guys, this is very important because you will see as you continue doing some problem here in the application of calculus, you will have to recall this fact that at a point of contact, the gradient, the graph, which is f at x, and the tangent have exactly the same gradient. Okay, let's continue. So because of that, now let us quickly find the equation of a tangent here. The equation of, sorry, not the equation of a tangent. Let's find the gradient of this line at this point. Okay, let's go back. Let me put this here so that we won't forget what we are supposed to. This is what we want, by the way. Okay, so what we're going to do is that we'll say, okay, we'll say f at x, as we are given, it was nothing other than minus x squared plus what? Plus 2x plus 3. Okay, because we are looking for m, so we are going to find the derivative. So f prime at x, and then that is nothing other than you take this 2 to this side, so it's going to be minus 2x and then plus 2. Okay, you know the derivative of this one is going to be 0. The derivative of this is 2. The derivative of this is minus 2x. Okay, now I'm looking for the gradient at x is equal to 2 so that I can find m. So m is equal to f prime at 2, and that is nothing other than minus 2, and then I have this 2 here plus 2, and then minus 2 times 2 is going to be minus 4. Minus 4 plus 2, it's going to be what? It's going to be minus 2. So therefore, let me write with a different color. Therefore my m is equal to minus 2. Okay, does that make sense? Okay, so I've got m, which is minus 2. Okay, now this one is sorted. I have m now of the equation of tangent. So what am I short with? I'm short with c. How do I get c? You know, in order to get c, what you need to do, because you've already found the gradient of this line that you do not know, you can then update your line and say you've got y, which is equal to what? Minus 2x, the one that you do not know, and then plus c, because at the moment you do not know what the value of c is. Right? Now, so what you need to do is you need to find any point that lies on this graph, and then you must then substitute the y value of that point here and then substitute the x value of that point here. All right? Okay, so you can already see that we already have the x of this point because that is where they touch. So both the curve and the tangent, they touch this point. So this point does touch what? The tangent. So the x of that point is 2. Now how do we find the y of that point? So how do we find the y of that point? So we know that x is equal to 2 is x of the point that the tangent passes through. You don't have to write this, I'm just writing it for your information, but during the exam you don't have to. Okay, passes through. Okay, so because of that you need to find the y value of it. So how to find the y value of it? You must take this x and substitute it at this equation. Okay, substitute this equation and find the x value of it. So you will then have f at what? At 2, which is equal to what? Minus, and then you put this 2 squared plus 2, and then plus 3. Okay, minus 2 squared, what is it? It's 4, and then plus this 4, they're going to cancel each other, and then you're going to remain with 3. Okay, so this point that the tangent passes through is what? Is the x of it is, therefore the point is, the x of it is 2, and then the y of it is what? Is 3. Okay, you haven't found C yet. You've just found a point that this line passes through. Now, when you have found that, what is it that you then do? All right. And guys, please don't be traumatized by this lot of things. It looks like it takes long but when you've clearly understood it and you start doing it over and over, it becomes far better. If I was doing it myself, I would have been done in less than 5 minutes. It will also be that with you. In maths, you must learn to be patient. So when you learn something for the first time, it always takes longer. But the more you do it, then it gets easier and easier and easier. Okay, so don't be terrified at all. Okay, so you've got this incomplete equation of a tangent, and then you've got a point that it passes through. Okay, so now what do you then do? You say, okay, you've got y, which is equal to minus 2x plus c, right? And then what you simply do is you then take this 3 and then you put it here. So what do you get? You get 3 is equal to minus 2, and then there's a value here, which is what? Which is 2 and plus c. All right? And then what do you then do? This will then give you what? 3 is equal to minus 2 times 2 is gonna be minus 4 plus c. And then you take this 4 to this side, it's going to be plus 4. So c, so you're going to have 3 minus, so it's not minus anymore, because when you take minus 4, this side being minus, when you put it this side, it's going to be plus. So 4 plus, so 3 plus 4 is equal to c. That means c is equal to what? Is equal to 7. So your graph is what? Let me write it with the. So your graph will then be y is equal to what? Is equal to minus 2x plus 7. So this is your final answer. All right? This is your final answer. So the equation of a tangent of this graph at this point is nothing other than what? Is nothing other than minus 2x plus 7. All right, guys, let us now take this question. I want to prove to you that in actual practice, this thing is faster than the way you saw it. Okay? So they are saying, so consider the function f at x is equal to 2x to the power 3 plus x squared minus 4x plus 6, and then determine the equation of a tangent to the function at x is equal to 4, right? So we know that it's y, the equation of a tangent must be y is equal to mx plus c. So what do we need to find? We need to find m and c, and we know the story of m, that we get it through the derivative at this point. So we then say f at x is 2x to the power 3 plus x squared minus 4x plus 6, and then f prime at x is nothing other than what? Is nothing other than 6x squared plus 2x minus 4. And you know how to find the derivative. We discussed that. If you do not know, go back to the other video in this channel that speaks about how to find the derivative. You will see how to find it. Okay, so, and then we know that m is nothing other than f prime at what? At 4, which is what? And why is it that? Because the tangent and what? And the graph at the point of contact, they share what? They share the gradient. Okay, so you could have 6 and then 4 squared plus 2, and then you've got 4 minus 4. You don't have to worry about this. You can quickly do it on your calculator. Okay, you say 6. You put it exactly as it is, and then what do you get? I'm also lazy to count with my head today. I usually count with my head, and then you get 36. Okay, so your m is equal to 36. Okay, so you've got an equation y is equal to 36 x plus c that you do not know, and then you need to find the x value that goes together with this point so that you can substitute here as a point that passes through this line. And then how to do that? You take this 4 and then you put it in this equation. And then guys, I think I should mention this, that sometimes when they won't say x is equal to 4, they will give you the whole point, so you won't have to find the y value of it. Okay, but this time around they only gave you the x point, so you need to find the y value of it. Okay, and then we don't have any other clue. Sometimes we do have other clues in which we can use to find c, but now we don't have. The only choice that we have is to take this and put it here. So how do we then do that? You will then say, okay, you put this here in the calculator. Okay, I'll come with an answer. You can also do yours on the side, and then okay, so on my side I come up with 134. Okay, so the point is what? The point is x is 4, and then the y is 134. So when you substitute this, what do you get? So the y must get here, so it's 134 is equal to 36, and then the x is 4, and then plus c, and then 36 times 4, what do you get? 36 times 4 is nothing other than is 144. So you've got 134 is equal to 144 plus c, and then you take this 144 to the side, and then you say 134 minus 144, and then what do you get? You get minus 10. So c is equal to minus 10. Okay, and then so you then get what? You then get you can get y, which is equal to 36 x, and then minus 10. This is the equation of a tangent, right? All right guys, so as mathematicians we always encourage different ways of looking at things. So when you've got this, and then you've got this point which is 4 versus 36, now is there any other way of finding the value of c without having to do anything? Is there a way to do that? Yes, there is a way. Okay, so basically what you did now, you used y is equal to mx plus c, but there is other equation of what? There is another equation of a line, which is y is called y is equal to y1 is equal to mx minus x1. So in this case, x1 y1 is what? Is a point that is in this tangent, and then obviously m, as you know, it is a gradient. Okay, so you just need to find a gradient and then a point, which is this one. And then so instead of going through all of these things, what you simply do is you take this gradient. So some of you will use this method, but some of you will prefer this method. I'm not going to choose for you. You must choose for yourself. Which one do you identify more with? Okay, so if you choose to do it like that, you will then say y, and then y1. What is y1? Y1 is 134. So y minus 134 is equal to m. What is our m? Our m is 36. 36 times what? Times x. Now, our x, we keep it like this, and then what is our x1? Our x1 is this 4 minus 4. Okay, and then what do we then do? We say y minus 134 is nothing other than what? So 36 times x is going to be 36x, and then 36 times 4, what is it going to be? It's going to be 130. It's going to be 144. So minus 144. And then when you take this to this side, you end up with y is equal to 36x minus 144 plus, because this is negative here, so when you put it to that side, it's going to be positive. It's 134, and then you end up with y is equal to 36x, and then minus 10. Can you see? This and this are exactly the same, but what did you do? You used different method. Okay, so you can either use this method in this part, or you can go straight and use this one. It is totally up to you. Ladies and gentlemen, personalities, thank you for tuning in. This is Mqondisi Magaba from Thembela Maths Club, a club that helps learners to understand mathematics. So thank you for watching this video. Guys, if there is a friend of yours that you think can benefit from this video, please don't be jealous. Share with them. Okay, share with them so that they can also watch and benefit. The reason why I do this kind of videos is to make you guys benefit, and so that you can pass. I want you guys to pass. Okay, so you must pass. So please share this video with someone that you know, your colleague, your friend, your classmates, or whatever, to share. Thank you and goodbye.